All right, so here's the Unit 1 study guide for Math 2. So it says use a figure to name the following. So these are review questions from Unit 0. In addition, state the relationship between the angles, congruent, supplementary, complementary, and they say that lines A and B are parallel. Okay, so first one's asking for alternate interior angles. So remember, the alternate part means that we're on opposite sides of the transversal and on the inside of the parallel line. So 3 and 5 would be considered alternate interior. 4 and 6 would also be considered alternate interior. So I'm going to say angle 3 and angle 5. Remember that alternate interior angles are congruent. Next one is asking for same side interior. So when we're saying same side, we mean on the same side of the transversal and on the inside. So for instance, 3 and 6 would be same side interior. 4 and 5 would also be same side interior. And remember that same side interior angles are supplementary. All right, next one is asking for alternate exterior. So again, alternate are on opposite sides of the transversal. Exterior meaning on the outside. So for instance, 2 and 8 would be alternate exterior, or 1 and 7. Alternate exterior angles are also congruent. All right, the last one is corresponding angles. So corresponding angles are matched. So if we think of this as one group of angles and we think of this as one group of angles, we want them to be in the same position. So for instance, 2 and 6 are both like kind of in the top part here. 3 and 7 would be corresponding, 4 and 8, and 1 and 5. So I'll say angle 2 and angle 6. And corresponding angles are also congruent. All right, next set of questions, it's asking us to solve for the variable in the diagram and find the measure of angle A and angle B. Show all work. So for this question, we have 4z minus 14 or plus 14, and that's this angle. And then we have 14z plus 4, and that's this angle. Well, those two angles are same side interior angles, which means they're supplementary, which means we're going to add those together. So 4z plus 14 plus 14z plus 4 and set it equal to 180. So these are same side interior angles. And we know that they're supplementary. So to solve, we're going to combine like terms. So we have 4 and 14 make 18z. And then we have 14 and 4, which is going to give us 18. Now we're going to subtract 18 from both sides. So this is 162 is equal to 18z. And then we're going to divide by 18. So I get z is equal to 9. So we've done the first thing. We've solved for the variable. Now they want us to find the measure of angle A and angle B. So angle A is this angle right here. So now that we know z, let's go ahead and plug it in up here. So 4 times 9 plus 14, and that's going to give me this angle right here. So 4 times 9 is 36. Then we have 36 plus 14, which gives me 50. So let me write it in the proper spot. So this angle, well, it's kind of hard to point to. So this angle right here is going to be 50 degrees. And we know that these are supplementary. So when I plug in 9 for z here, 14 times 9 plus 4, that's going to give us 130. So this angle right here is 130 degrees. All right, so now they want us to solve for the measure of angle A and the measure of angle B. Well, angle A is vertical to this angle, which means the measure of angle A is going to be 50 degrees. And I'm going to say that's vertical to the 4z plus 14 angle. Then to find the measure of angle B, well, I'm just going to say that angle B and the 4z plus 14, or actually angle B and angle A are actually corresponding. So the measure of angle B is just going to also be equal to 50 degrees because it's corresponding with A. All right, the next question is asking us, A, B, and CD intersect at point E. They want us to know Is triangle AED similar to triangle BEC? So for this one, we're either going to be using AA, SSS, or SAS to prove that these two triangles are similar. If I look at the information given, I'm only given two pairs of sides, which means the only one that I could possibly use is SAS. So let's see if we have enough information here. Well, I know my angle is taken care of because I know I have vertical angles here. And we need our sides to be proportional. So let's go ahead and check our sides. So I'm going to use the order of my letters to make sure that I'm matching up the appropriate side. So I have AE here. So AE is going to match up with BE. So I'm going to put those two together. So I have 2 over 1. I have to check to see if that's equal to DE. So DE, which is going to match up with CE. So it's going to be 3 over 1.5. Well, 2 over 1 is 2, and then 3 over 1.5 is also 2. So this is going to show me that I have proportional sides, which is what we need for SAS. Well, and we also know that we have a congruent angle. So we know we have angle AED is congruent to BEC because they're vertical. So now we have our two sides and our angle, so that's enough to show SAS. So then we would say triangle AED is similar to triangle BEC by SAS similarity. All right, taking a look at question number 2. So again, we're wondering if the two triangles are similar. So again, we have 3 ways to show that: AA, SSS, or SAS. I look at the information given. In this diagram here, I don't know any information about the sides. So if I don't know any information about the sides, then it means that we're going to be checking for AA. Well, we know we all already have one pair of congruent angles, and we know anything that looks like a bow tie shape, we can also mark vertical angles as being congruent. So now we have our 2 pairs of angles. We can go ahead and show our evidence. So I'm going to do this as a 2-column proof where we have our statements and our reasons. So the first one I'm going to say is angle G is congruent to angle V. And we knew that because that information was given to us. The next thing I'm going to state is my vertical angle. So I have angle GHF is congruent to angle VHW. And those are vertical. That's enough information to show angle. So now we can conclude that the two triangles GHF are similar, and triangle VHW. And then our reason would be AA similarity. All right, taking a look at question number 3. Again, it's asking, are the two triangles similar? So we have 3 options: AA, SSS, or SAS. So let's look at the information that we're given in this problem. Well, in this information, I see that I'm giving all 3 sides. I don't have any information about the angles, which means if these are similar, they're going to be similar by SSS. To show SSS, we have to show that all the sides have a common scale factor, meaning the sides are proportional. Okay, we can use the order of the letters to match up, but we can also use the size of the sides. So if I say JL is going to match up with FG. Those are the small sides, right? 48 and 104 are the smallest sides. So I'm going to do the big over the small. So 104 over 48. Next side I'm going to look at here is going to be the medium side. So that's going to be 117, which is GH. So that's going to match up with LK. That's the 52. So I'm going to do 117 over 52. Okay, by process of elimination, we just have our last side. This is the longest side, 156 over 72. So we need to check to see if these 3 ratios are equal. So I'm just going to put them in my calculator. All right, so when I put those in my calculator, 104 over 48 is 2.16 repeating, 117 over 52 is 2.25, and 156 over 72 is 2.16. So even though these two pairs of sides have the same scale factor, this one does not. So these are not equal, which means we do not have proportional sides, so we would say not similar because the sides are not proportional. All right, taking a look at this last one here on this page. So it's asking again, are the two triangles similar? So we have our three options, right? AA, SSS, or SAS. And if I look at the information given, all I'm given information about are the angles. I know nothing about the sides. So if these are similar, they're going to be similar by AA. So we need to find two pairs of congruent angles. Well, I already see one. I see this angle and this angle. Those are clearly congruent. However, 42 is not equal to 63, but we know triangle sum theorem. We can solve for the third angle in this triangle using triangle sum theorem. And then if that matches the other angle, then we know that they're congruent. So 75 plus 42 is going to be 117. And I'm going to do 180 minus 117, which is 63. Which means that this angle is 63 degrees. Well, there's 63 and here's 63, so we have our two angles. So now we can go ahead and do our proof. So we know that angle K is congruent to angle P. And remember, that information was just given to us. It was already on the diagram. And then we determined that angle L was congruent to angle Q. That information wasn't given to us. The way that we determined that is by using triangle sum theorem. There's 180 degrees in a triangle. That's all we need to show for AA. So now we can conclude that LMK is similar to triangle QRP, and our reason would be AA similarity. Now let's take a look at this question here. It's asking us to find the perimeter of triangle ABC. So we want to find the perimeter of this triangle right here. Well, in order to find the perimeter, we have to know all the sides. So we need to solve for the missing sides. So I'm going to call AC X. I'm going to call BC Y. And we know that these two triangles are similar, which means they have a common scale factor or their sides are proportional. So I know that my scale factor can be 25 over 15 or 15 over 25. So I'm just going to go 15 over 25. Equals x over 12. And then I'm going to go ahead and cross multiply. So I'm going to solve for x first. So 25 times x is 25x. And then I'm going to do 15 times 12, which is 180. And then I'm going to divide by 25. So x is going to be 7.2. Now I'm going to solve for y. So I'm going to use the same scale factor, 15 over 25, and that's going to be equal to y over 36. And again, we're going to go ahead and cross multiply. So 25y equals 15 times 36, which is 540, and then divide that by 25. So we get y equals 21.6. Since we're looking for the perimeter, we know we want to add those all together. So it's going to be 7.2 plus 21.6 plus 15. So my perimeter is going to be 43.8. We don't have any units, so I'm just going to say units. All right, looking at number 6, they want us to solve for x and y. It's telling us that AD, BE, and CF are all parallel. So this is just using one of our triangle proportionality rules. And we know that those parallel lines divide up our sides proportionally. So we can set up a proportion and solve. So first I'm going to solve for x. And I can match up x with the measurement across from it. So it's going to be x over 24 equals... and then I'm going to go over here to my left, so 60 over 45. We need to make sure we're being consistent with how we set it up. So since I went from the bottom to the top for my first ratio, I need to go to the bottom to the top for my second ratio. Then I'm going to go ahead and cross multiply. So I have 45x equals 24 times 60, which is 1,440. And then divide that by 45. So I get x is equal to 32. And then we can do the same thing to now solve for y. So to solve for y, 3y minus 2 corresponds to the measurement across, which is 33. And then we're going to use the same ratio here, 60 over 45. Okay, so again, we're going to cross multiply. So for here, I'm going to do 45 times 3y minus 2 is equal to 60 times 33, which is 1,980. Now we need to distribute. So 45 times 3 is 135. So we have 135y. 45 times negative 2, which is going to be negative 90. And then we're going to add 90 to both sides. So 1980 plus 90 is 2,070. And then we're going to divide by 135. So we get y is equal to 15.3 repeating. All right, so moving on to question number 7. So this is angle bisector. So we see that we have this line right here, which bisects this angle, which means it divides up these sides, this side and this side, proportionally. So we can set up a ratio. So we can do y over 28 equals 9 over 21, and then we can cross multiply. So we have 21 times y, which is 21y, and 28 times 9, which is 252, and then divide by 21. We get y is equal to 12. All right, same thing for b. We have angle bisector, which means we can set up a proportion. So I can do 20 over 24 is equal to 2y over 2y plus 2. It's important to note that I set it up from here to here and then left to right, but you could also set it up as 20 over 2y equals 24 over 2y plus 2. Either one would work. All right, now we're going to cross multiply here. So when we cross multiply, let's be careful that we're distributing to everything, not just to the 2y. 2y times 24 is equal to 48. So now we're going to distribute. We have 40y plus 40 is equal to 48. Just 48y, sorry. Now we want to get y by itself. So I'm going to subtract 40y. So 40 is equal to 8y and divide by 8. So I get y is equal to 5. All right, question number 8. It's telling me that M is the midpoint of BC and N is the midpoint of AB. Well, if those are the midpoints, that tells me that this line right here is the mid-segment. And if that is the mid-segment, then we have triangle mid-segment theorem, which tells us that if we have a mid-segment of a triangle, it is half the measure of the side that it's parallel to. So they tell us that AC is 15. They tell me that NB is equal to 3. So that means I can solve for the length of MN, or NM, I guess, in this case, how they ask it in the question. So NM is just going to be half of 15, or 15 divided by 2. So NM is equal to 7.5. It's also asked me for the length of NA. Well, they tell us that N is the midpoint. So if NB is 3, that means NA will also be 3. And the reason for that is because N is the midpoint of AB. All right, so question number 9 tells me that I have my eye, which is 67 inches above the ground, and you're 52 inches from the mirror, and it says you are 147 inches from the palm tree. We want to know how tall is a palm tree. Okay, well, here we have two triangles that are similar. We know that the angle that the tree and the person makes with the ground is 90 degrees. And then the angle coming off the mirror is also going to be the same. So these are similar by angle, which means we can set up a ratio here. We do need to be careful because the measurement that they give us, that 147, is not the distance from the mirror to the tree or the bottom of this triangle. So I have to subtract these two numbers. So 147 minus 52 is 95. And that's going to give me the length of the triangle on the base of the triangle. So now I can go ahead and set up my ratio. So x over 67 is equal to 95 over 52. And I'm going to cross multiply. So I have 52x is equal to 67 times 95, which is going to be 6,365. And then I'm going to divide by 52. So I get x is equal to 122 we'll round to the nearest tenth, 4, and our units in this case is inches. All right, now moving on to the dilation questions. They want us to dilate the image by a scale factor of 2, centered at the origin. So I'm just going to write out the coordinates of each point. So D is at the origin, E is at 1, 3, and F is at 4, negative 2. If we are dilating by a scale factor of 2, that means we're just going to multiply all of these by 2. And that's going to give me my new coordinates. So now I have D prime. That's just going to stay at 0, 0. E prime is going to be 2, 6. And then F prime is going to be 8, negative 4. So I can plot those. This is going to be D prime. Then we have 2, 6. It's going to be E prime. And then we have 8, 4. All right, number 11, they want us to draw and label the pre-image and image. So first I'm going to plot my points. So P is negative 6, 4. Q is negative 2, negative 2. And R is 4, 0. And now we're going to dilate by a scale factor of 1/2. So we're going to be multiplying these all by 1/2. So that tells me that P prime is going to be negative 3, 2. Q prime is going to be negative 1, negative 1. And then R prime is going to be 2, 0. So negative 3, 2. That's P prime. Negative 1, negative 1. Q prime. And then R prime. So this would be a reduction. All right, question number 12. It's asking if the transformation is an enlargement or a reduction. So to figure out which one's the original, which one's the new, we want to look for prime notation. So as we can see here, the bigger figure has the prime notation, which means this is the new figure, which means our shape got bigger. So this is going to be enlargement because the new figure is bigger. So now we can determine the scale factor of dilation. We can do that by comparing side lengths. So if I look at the side length of A from A prime to B prime, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I compare that to AB, 1, 2, 3. So it was 3 and it became 9. Remember, you can always get your scale factor by doing new over old. So my scale factor here is going to be 9 over 3. So my scale factor is equal to 3. All right, looking at number 13. Again, I'm looking for my prime notation. So my prime notation is on the smaller figure. So this is going to be a reduction because the new figure is smaller. And again, we can compare side lengths here. If we can't compare side lengths, we can always also compare coordinates since it's dilated from the origin. So if I count here, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. So it was 8 and it became 4. So remember, we can do scale factor. It's new over old, so 4 over 8. That's going to give me a scale factor of 1/2, or 0.5.